Welcome to qnawire.
This is the diagram given in the question. So there is point, it's given as point A, B, C, D, and the measurements is given in feet and kips. 10 feet and 10 feet and 5 feet are the distances given, and there are two forces, 10 kips and 10 kips in C and D points. And here we can see in the joint B, the point B, there is a roller support. So as that is a roller support, there will be an external horizontal force. Let's call it as HB. And in point A, there is a pinned support. And we know if there is a pinned support, there will be an external horizontal as well as vertical force. And let's name the vertical force as VA and the horizontal force as HA. So now let's draw the free body diagram of entire truss. So this looks like the free body diagram of entire truss. So HA is the horizontal force in point A and HP is the horizontal force in point B, and the 10 kips force are given in the question itself, and VA is the vertical force in point A. So let's calculate the equations at equilibrium. So for calculating the equations at equilibrium, we have to resolve these along y-axis as well as x-axis. First, let's resolve this along y-axis. So summation of y equal to 0 gives VA minus 10 minus 10. That is, this VA minus this 10 minus this 10 equal to 0. So we will get VA equal to 10 kips. Now let's resolve against x-axis. Resolve along x-axis gives us summation of h equal to 0, that is HB into the distance 5 feet equal to the 10 into this distance 10 and plus 10 into the whole distance 20. So we will get HB equal to 60 kips. So, and likewise we can find the value of HA, that is also will be 60 kips. So now let's resolve, let's find all the other things by resolving individual joints. Let's name this joint as A and the other as B and C and D. So first let's draw for the joint B. There will be SAB along vertical axis and SBC and HB along horizontal. So first resolve along x-axis, that is summation of x equal to 0 SBC. This SBC will be equal to HB, and we know the value of HB as 60 kips. So the SBC will also be 60 kips. And as this force is coming inward to the point joint B, so this will be compression. Let's notate the compression as C. So SBC will be 60 kips compression. And let's resolve along y-axis. there is only one force along y-axis, SAB, so SAB will be 0. There is nothing else in y-axis, so SAB will be 0. Now let's draw for joint B. Let's find what will be for the joint B. There will be a horizontal force SCD and the 10 keeps vertical and SAC making an angle called, let's call it as alpha, and SBC. So let's find the value of angle alpha. We can find it by taking the tan of alpha, that is adjacent by opposite. The adjacent is 5, opposite is 10 feet, so tan of alpha is 5 feet by 10 feet, so we will get alpha equal to 26.565 degree. Now let's resolve this along y-axis. That will give us SAC into sine alpha equal to minus SAC into sine of alpha will give us it along y-axis. So that minus the other thing along y-axis is 10 kids. So that minus 10 kids is the thing. So that minus 10 kids equal to 0. So that will give us the value of SAC. So we can find the value of SAC from this. Alpha we already know as 26.565. Substitute that value and we will get SAC as 22.3607. That is also kids. So we got the value of SAC, and here the SAC is going out, so that is tension. Let's indicate it as T. And the above SBC is going inward. In case of joint B, SBC is going inward, so it's compression. That's why we denoted it as C. So now for the point joint C, let's resolve along x-axis. So summation of h equal to 0 gives us minus, this is this direction. So minus SCD plus 60 means we already know the value of SBC, it's 60. So minus SCD plus 60 minus this SAC into cos alpha will give us this vector resolving along x-axis. So minus SCD plus 60 minus SAC into cos alpha equal to 0. So we already got the value of SAC and we know the value of alpha. So by substitution we can find the value of SCD as 40 kips. So we got the value of SCD also, and SCD is going inward to the joint C, so that is compression. Let's denote it as C. Now for the last let's draw the about joint D. So about the joint D, this looks like the joint D. There is a SAD making an angle. Let's name it as beta, and SCD along horizontal, and the 10 keeps given in the question. So like previous, let's find the value of beta. So it's opposite its opposite by adjacent. So opposite side is 5 feet, adjacent side is 20, that is adjacent side will be 10 plus 10, that is 20. Opposite side will be 5 feet, so this angle is the beta. So yeah, we will get the value of beta as 14.036. So this is the value of beta. We got the value of beta. So now let's resolve along y. Yeah, the summation of y equal to 0, that is SAD into sine beta. SAD into sine beta gives us this vector resolving along y-axis. So SAD into sine beta minus 10 minus this 10 minus this 10 will be 0. So we know the value of beta. Let's substitute and we will get SAD equal to 41.2317 kips. So we got the value of SAD also. And we can find this SAD is going out. So that is tension. Let's denote it as T. So that's it. And yeah,